Hello, this is Craig Little. I'm here to talk to you today about some live patching methodology, and I'm one of the SEs for North America, and I've been working with a lot of my customers over the last number of years at this point around live patching. It really provides a great solution set for working with the patches, being able to achieve those sometimes unreasonable expectations around the patch deployment. You might be given days or hours in which to get a patch deployed in your environment, and you're trying to do that while still maintaining uptime and things of that nature. And I had a quick analogy that kind of hit me a little bit earlier today, where thinking about live patching. Think about a life raft. You're in a life raft floating around shark-infested waters, and you got holes popping up and a roll of duct tape. In this analogy, you need to be able to patch those holes quickly, effectively, and without doing a lot of testing to make sure you don't end up swimming with the sharks. And so it might be a little bit of a reach analogy wise, but this is something to kind of kick around in your head as we're talking through this live kernel patching methodology. How do I take this technology and incorporate it into a patch methodology? So let's take a look at what is live kernel patching. It is that ability to patch my environment quickly and easily with my security and stability updates without stopping the kernel. It's really very, very simple. For SUSE, we're calling it KLP in version 15, a little bit different name than what we had in version 12. So something to kind of keep in mind if you're working in both versions. SLES 15, live patching KLP, we are providing that as a solution set to be able to get those patches in without stopping the kernel. One of the things to keep in mind here is the fact that the live kernel patches are a subset of all the patches that are available to the environment or to that version. And so that's something you want to kind of keep in mind as you are working through how do I update my pieces. Not all patches can be deployed via the kernel, and not all of those security and stability updates are needing to patch inside of the kernel. Sometimes it's those external packages, external to the kernel that is, that need to be updated. So one of the things to keep in mind is the KLP is actually a merging of two live patch technologies where we have Kdrat from SUSE, Kpatch from Red Hat, and these two were pulled together and merged by the kernel group, kernel.org group, into one methodology for the Linux kernel. It's kind of cool because now that allows us to have that technology potentially on additional distributions and something that we all will want to utilize. One of the things that happens though is we changed up some of the names of the modules, and we now have KLP as our primary status tool for letting us know the status, what patches are in place, what blocking processes might be in place, but we're going to talk about that in a little bit more detail. Additionally, we have Zipper Lifecycle. Zipper Lifecycle is an add-on to the Zipper tool that allows you to see what live patch bundles are available for each of the systems that you're using it. So now, dynamic software updates, really just the generic term for kernel live patch, has really been around for a while. Everybody loves this concept of, can I deploy a patch to the environment without having to restart the process? You know, even back in the 1945 timeframe, nobody wanted to restart the process. In this particular case, it was a long-running calculation that took 3 months to complete, and they wanted to correct errors in how things were calculated, errors in the coding, without having to restart the whole process. And so they came up with this concept of color-coded punch cards to enable them to understand what pieces of the code could be modified and modify them in a chunk, insert the new pieces in, and away they would go. And so it was a good solution set. This concept of dynamic software updates has been around for quite some time. As we take a look at some of that modern history, the goal remains the same. How do I fix my bugs, potentially add features, take care of security issues, take care of stability issues, without replacing the whole program? That's that key element. You want to make sure you don't have to replace the whole thing. And in our case, we want to be able to do it live without having to shut down the environment. So Kdrat was developed by SUSE back in that 2014 kind of time frame, but it kind of built on all of these other pieces. If you take a look at the timeline at the very bottom of the screen, you will see those in green. And it's those pieces that really have influenced the Linux-based dynamic update utilities. So Ksplice came out in the 2008 timeframe and was good stuff, but got gobbled up by Oracle in the 2011 timeframe, and was made closed source at that point. Kpatch, Kdrat came out in the 2014 timeframe, Kdrat by SUSE, Kpatch by Red Hat, KLP in the 2016-2017 timeframe, where the Kernel.org group merged those two pieces, Kpatch, Kdrat, and took the best of both to make this new technology. One of the things of pulling these together and making a methodology that's available via the kernel is we're still not completely caught up with the feature set that enterprises want. So we're still working on that piece from a kernel.org kind of perspective and at SUSE to give the best enterprise grade live patching capability around. So we're working on it. We've come a long ways. From a SUSE version perspective, live patch in Kdrat was available in SLES 11 if you had a premium support engineer. Initially available to the general public in version 12. So that's been quite some time. We just now, just this last winter, released Service Pack 5 of SLES 12, which is the last service pack in that version family. And so that means we're in about the 6-year time frame that we've had live patching available for public consumption. And then in version 15, it's been there the whole time as well. So let's take a look at what makes live patching work. At its core, it's really, really very straightforward. I'm going to take and patch a new function. I need the old function. When it gets called, I need to do a no-op redirect over to the new function and then return the results of whatever it was supposed to do. So you think about that. Yeah, easy. Just have the old function, drop it over and say, hey, there's a new one right over here. Send the data over, get the results, return it back to the calling function. In reality, there's a whole lot more to it than that, because we have things like function inlining, which is where a compiler may take a simple function and instead of making calls back to the original, it just goes out and copies them. And while it's efficient for some environments, it makes it difficult to patch in that space, because I'm patching to known functions and all of a sudden there's 15 other functions that were copies of it that I also have to take care of. This is where Dwarf is used, and Dwarf is really a solution to do a stack unwind to verify that we have all of the functions that we need to patch. Static symbols. Oftentimes code will use either static symbols or unexported symbols that we need to pay attention to from a patching perspective. How we look at fixing that is this k-all-syms, where the kernel keeps a list of all of the symbols. So that helps us out on that patching piece. IPA SRA, and this is one that I'm going to actually read off of my screen over here because I can never remember the specifics. It's interprocedural scalar replacement of aggregates. Essentially, this is similar to what we were talking about with function inlining, where we just copied functions because it was more efficient. This is the same thing, where compilers can optimize the code in a way that makes it difficult to patch. So this is something where we really need to kind of pay attention to these pieces, and it makes for live patching very, very complex. multiple functions, multiple dependencies. Again, this is all part of that consistency model that we're going to talk about in just a minute on the next slide. Eternal sleepers, processes that are hanging out, just waiting for something to happen. While if they're sleeping, they're not a security risk if this is a vulnerability that we need to patch. But the other side of it is this also means it may take forever to get these patches put in place without doing some major effort. So what we do here is we have this ability to send a signal to wake them up, to kick them off, and make sure they're going and getting the new code. State transformation, this is one of those things where we've got to make major transformations in the kernel, and right now we're still working on how do we achieve that in a clean, easy way. And then the last piece is third-party kernel modules, which are often device drivers, things of that nature, where they're coming in from third-party, and we're not even sure how to get them patched. So those are some of those pitfalls, those things we have to pay attention to as we're looking at live patching. So this is not as simple as, I just redirect to the new function call. I wish it was. I really do wish it was that simple, but not so much. So let's take a look at what we have from a consistency point of view. And we're going to look at how Kpatch did it, how Kdrat did it, and how we've come together to achieve it in KLP. So let's take a look at the Kpatch side of things. And they did a process where they would halt the kernel to be able to make sure, check the stacks, do the stack unwind using that dwarf process that we talked about, to make sure they went and found all of the functions that needed to be updated, got them updated, and get it up and running and turn it on. Worked, required a halt of the kernel, and potentially caused some application issues, or at least a pause in the execution of everything that's going on. But by halting the kernel, they were able to achieve some level of speed to where it wasn't too bad, essentially achieving that live patch kind of concept. Kdrat went what we call a lazy migration route. It's a little bit different approach because instead of stopping the kernel and examining the whole stack, we went and did this on a per thread basis. By doing this on a per thread basis, that allows us not to halt the kernel. We go and just look for the affected threads and we go take care of them and allow them to move forward, get them fixed. We wake up the sleeping threads by sending those signals. And then once we've gone through all of those pieces, we're done. But we didn't halt anything. We kind of waited for some threads to naturally close out and then execute new again. And part of our tool would tell you which processes still had not been updated. So normally this was in a couple of seconds, but it could potentially take quite some time for those threads to release and come back. So these were the two methods of Linux live patch, Kpatch, Kdrat, and Ksplice was very similar in that it used that stop kernel kind of concept. For KLP, we've changed it and merged these pieces. So we combine that concept of stack checking using the dwarf unwinder, these pieces, because that allows us to deal with some of those pitfalls. The function inlining that we talked about, the compiler optimization, these sorts of pieces. And this is one that really allows us to handle some of those complex types of patches that need to be deployed. And then the kernel thread model cleanup. And that's one where SUSE, we're working on these pieces. This allows us to go touch the threads and deal with the thread pieces and be able to take care of them. By having both options, being able to do the whole stack side of it and the individual thread side of it, it gives us a lot of flexibility in how we approach deploying live kernel patches. But it takes time to get these pieces right. They are not simple hello world type of code, but very, very complex code that we want to make sure gets executed cleanly, completely, every single time. So we're moving forward. Let's switch from how live patching works into what is your live patching policy. or what is your patching policy, excuse me. From a patching policy point of view, I went and talked with a handful of my customers. Being a sales engineer, I get to go talk to customers all the time. And so I hit a variety of my customers up with the question, what is your patching policy? What has the security team, what has the governance team, what has whoever team has dictated these policies, what have they set for you for patching your Linux environment, and what are these requirements? So one of the more restrictive, faster timelines that I found out about was one where all security updates have to be patched 10 days from release. Critical updates have to be installed within 72 hours of vendor release. Important and moderate patches need to be patched in that 90-day kind of time frame. In looking at these requirements, you're going, okay, 10 days from release. Yeah, that's somewhat doable. Critical updates, 72 hours. It's 3 days. 3 days to get a patch tested or deployed, tested, and then deployed to production. And oh, by the way, I've got to get change control and a downtime window in there if it's going to end up requiring a reboot. How do I achieve some of those sorts of things? This is one of those times where having the only tool be a hammer is not the right approach. You can't just push these things through and hammer, the square peg into the round hole kind of concept. So if you have these kinds of policies, how do you achieve them today? Most of the administrators, and when I was administrator, this would have been my methodology at the time as well, is I would end up spending nights doing patch deployments, getting my app owners to come in and do testing once I got things patched in the dev, test, UAT types of environments. It would have been next to impossible to hit that 72-hour kind of window. One of the good things now, as you'll see us work through how live patching fits, you'll find that we have that ability to hit that 72-hour window. Even though at that first blush, we look at that and go, damn, that's just unrealistic. I'm not going to be able to hit that window because I got to take this through 5 different groups of people in my environment, 5 different management chains, and I got to get time and effort from all of these guys. I've got to build change control, I got to build downtime windows, and oh yeah, I've got to take those critical business apps and shut them down for a period of time. And if you're looking at SAP HANA database with that in-memory database, some of those really large databases, you could be down for hours in just executing a reboot. Because you've got to make sure the database is out to disk, restart the system, and for some of those, you're talking terabytes of RAM in them. And so now I'm restarting the system, and it's going to take me time just to get the OS up. Now I got to read those multiple terabytes of data off a disk, come back into memory before I can start executing stuff. So you throw a 4-hour reboot into this overall process, and it's going to take, it's tough to hit that 72-hour release kind of cycle. So let's meet policy with methodology. So we get dictated a policy that says you have to do X by X time frame. At the core of it, the goal is to get those systems patched without causing any undue downtime. At least that's always my goal. I want to be able to keep my systems up to date, reliable, efficient, and secure without having to cause a bunch of downtime, without having to take users off of it, shut applications down, these sorts of things. How do I achieve that? I need to patch all of my systems based on those policies within the timelines that have been handed to me. There are times you might be able to push back, there's times you might be able to recategorize a system, but the overall goal is I need my production systems up to date, patched, ready to do the jobs that they're meant to do. And critical updates will always have those shortest timelines, especially zero-day vulnerability pieces where things can get compromised by these security vulnerabilities. So how do we meet those two together to where we can use the methodology, we can use these tools that we have available to us to be able to deploy quickly and easily? So let's take a look at LivePatch. Back to that life raft in the shark-infested water, LivePatch really is that duct tape. It's that piece that's going to allow you to stay afloat and not have to swim with sharks. Live kernel patch, again, as we talked about, is a subset of all patches that are available to Linux. It is the critical security and stability updates that we work with, and those are those key ones that fall into that 72-hour window anyway. So this allows us to provide that quick emergency response without having to take the applications down, without having to schedule downtime windows, things of that nature. And it allows us to do it in a quick and easy fashion. I can get stuff deployed to UAT within hours of the patches being released from the vendor. And the overall goal is to give you guys that ability to meet those, what on the surface looks like unreasonable deadlines, but meet them without impacting your end users. So that's we're going to look at using LivePatch to be able to achieve that. The overall methodology, let's take that critical security update. You have LivePatch, you have it for your UAT environments, and you have it for your production environments. So what we're going to do is we see that the very critical update has come out from SUSE. You take it, you deploy it to UAT within hours of it being released. Now you've got it in an environment that it can be tested. So that you got it out there quick, easy, you didn't have to update anything. You didn't have to take anything down, even though UAT you could probably arrange a downtime window, but not typically at an hour's notice. So this allows you to have those things out there deployed, ready to rock and roll, and you've got your app owners doing some testing on it to ensure that the application is not being impacted. While they are doing that testing, you now are scheduling the change control and a change window. Not a downtime window, but a change window, so everybody is aware, I'm going to deploy these pieces to production in this time frame, to where if there is any issues, they know exactly who to go look at, as opposed to having this, I don't know what happened, kind of scenario. But you can get all of that done while the testing is happening, and inside of that 72 hours, you've got your production environment also deployed. So now, that's all done. Production is all deployed, no downtime needed. You hit that 72-hour timeline, and security is looking at you going, how the hell did you pull that off? And you go, I'm good. You just go, I'm really good at what I do. Now, from this point on, you now take on the rest of those systems, because there's most likely production systems that didn't fall into that critical 72-hour window need for the deployment of these patches, or they weren't vulnerable, did not have this vulnerability. So now you can take on the rest of those systems, but now let's look at the rest of the patches, because overall, for those non-critical updates, the feature updates, things of that nature, those can be deployed if we remember back to what the policy is. I'm going to flip back here real quick. We were looking at security updates within 10 days. The good thing is, a lot of those security updates are probably going to be within that live kernel patch. So we'll get the critical updates, we'll get any other updates that need to be deployed, all in that 72-hour window. Then we can take a look at any other patches that are external to the kernel. Those that are in modules, OpenSSH, things of that nature, we can take a look at getting those deployed in that time frame. Most of those aren't going to require a reboot either. So now you can get all of these pieces deployed and ready to rock and roll inside of that 10-day time frame, and then you can go build out what that 90-day patch bundle needs to look like for all the rest of the patches and all the rest of the systems. So those dev test types of systems that fall into that category. So now let's move back to our example methodology here. So now you can focus on the rest of those patches because you've hit those very, very short timelines and have delivered on them and delivered inside of those. So one of the things to kind of keep in mind is there's two methodologies of dealing with patches in general as well as live patches. For those of you that are familiar with SUSE Manager, you can use SUSE Manager to push live patches as well as regular patches out to systems. If you're not familiar with SUSE Manager, I would highly recommend you take a look at some of the other sessions here at SUSECON that are covering SUSE Manager. It is a spectacular Linux management tool set. So patching, configuration management, CSV auditing, and all sorts of image management, container image checking, a lot of cool capabilities, including now monitoring and graphing of the Prometheus data, where we've incorporated Prometheus and Grafana into the solution set, as well as virtualization management. So KVM virtualization management. So an interesting mix of capabilities. Very, very capable Linux management tool set. Notice I didn't say SUSE Linux tool set. We manage SUSE, Red Hat, CentOS, Ubuntu, and OpenSUSE platforms inside of this one tool. It is a great single pane of glass to manage your environment from. So take a look at SUSE Manager and some of the rest of the SUSECON sessions, but SUSE Manager can be used to deploy live patches. Makes it even easier to get those patches out there in the timelines that the security and compliance teams are requiring. But for those of you with smaller environments, potentially, I know of a couple of my own customers that are like SAP users, where the only Linux servers they have are the HANA servers. And so for those guys, you can use pull updates, and you can just use Zypper to deploy those live kernel patches. Zypper has been extended, I believe I mentioned it earlier in the presentation, with this -kernel-live patch capability to be able to allow you to deploy or see what patch bundles are available for that system and get them deployed. So it's a great capability that can utilize the SEC or RMT repositories to deploy those updates to your systems. So two methodologies that can be utilized to deploy live patching in a very good way. So let's take a look at what we're doing from a roadmap kind of perspective. If we take a look here, we've got 15 Service Pack 1, which came out last summer in the July timeframe. And there's some tech preview on some userland live patching integration with other SUSE products, because we're looking at incorporating the live patching to fix or deploy patches to things like CAS, CAP, things of that nature, storage, and whatnot. So Service Pack 12 SP5, we added support for IBM Z for live patching. So not only is it x86 platform, but it's also Z. Very, very cool capability with the Z live patching. Early demos around userland live patch. 15 SP2, which should be coming out in the July-ish time frame this year. We're in beta. I believe we got a release candidate coming out shortly. But userland live patch will be in tech preview. The important part of userland live patching is the fact that not only can we patch what's going on in the kernel without shutting things down, but the goal is to patch things in userland, which are things like the OpenSSH, things like terminal windows, things that are running not in the kernel, but are running in userland. We can get them patched. They're also looking at deploying simplified patch management with this new piece. I have not actually taken a look at the beta. I'm kind of excited to see where we're at with those pieces. SP3, again, we're extending it out, making it even more capable on deploying those updates that you need deployed. So there's our roadmap. We've got some good stuff coming up. And for some additional resources, what I'd recommend is you take a look at the documentation. There's some blog posts that also talk about things around live patching. I would also recommend you go take a look at some additional SUSECON sessions that talk about live patching. But this is a great chunk of documentation. The live patch tools themselves are really very, very simple to deploy. The harder part is, how do I use those tools, whether it be Zipper, whether it be SUSE Manager, to fold that into my overall patch methodology? And that's always that key element. My sons love to work on their cars, and there's a point where you have certain tools that you have to get the job done quickly and easily and safely. And so this just becomes another tool in that toolbox of what you can use to deploy your patches and your updates. The key element is, how do I do it in such a way that I'm able to meet those compliance deadlines or security deadlines in a safe, easy fashion that doesn't require me to take systems down, doesn't require me to inconvenience the user. And so that's what live patching can get you, is everything's up to date, everything's secure, everything's patched, and my users aren't upset at me for causing downtimes. So there's what live patching is all about. Hopefully this helped you understand what's going on with live patching, how it works, and how you might employ it and incorporate it into an overall patching methodology. Thank you for your time today. I would highly recommend taking a look at some of the other SUSECON sessions, and hopefully you're having a great SUSECON experience in this new digital format. Thank you for your time and have a great day. Bye now.